Welcome to Lesson 8.2, Fundamental Properties of Area. So in 8.1, we looked at some of the basic ideas of perimeter. Now, obviously, building off of that, we're getting into the properties of area. So to begin with, we want to look at our definition of area. An area is the measure of space covered by a two-dimensional region. Area is always measured in square units. So if you're thinking about space, it's the amount of space covered by a two-dimensional region. Perimeter is just the measure of a boundary of that region. Area is the amount of full space it's covered. So that's why we have square units. So the main idea for this lesson is that the formulas for area of different figures are deduced from four fundamental properties of area. So breaking that down, we have the area postulate, which breaks into these four parts. The first part is the uniqueness property, which states given a unit region, every polygon region has a unique area. So if we're given any sort of region that's two-dimensional, it has a unique area. We have the congruence property, which says congruent figures have the same area. Then we have the additive property, which states the area of the union of two non-overlapping regions is the sum of the area of those regions. So if we have two figures that don't overlap, the area of their union would just be adding their two areas together. And then finally, we get the idea of the basic rectangle formula, which states the area of a rectangle with the dimensions L and W is L times W, or LW. So area of a rectangle, we always think of that as length times width. So these are the four pieces that make up our area postulate. So let's look at our first example dealing with area. Tells us rectangle ABCD is 25 millimeters wide and 40 millimeters long. Find the area of ABCD in square millimeters. So because it's a rectangle, we just take the length times the width. So 25 times 40 gives me 1,000 square millimeters. And I don't write it, or I don't care if you write your units as SQ, MM, or MM to the second power. Both still mean square millimeters. But then in part B, they're asking us to find the area in square centimeters. Now, I'm going to show you how to convert the units before you figure out the area. There is an approach to convert them after, but in my mind, it's a bit trickier. So we're going to go with the convert before the area. So we want to take 25 and 40 millimeters and convert them to centimeters. So there's 10 millimeters in every centimeter, so we'll divide both by 10. So we have 2.5 centimeters and 4 centimeters. So the area would simply be 2.5 times 4, which gives us 10 square centimeters, or centimeters squared. In example 2, it says a rectangle has a perimeter of 36 and a side that measures 8. Find the area of the rectangle. So from our last lesson, we know dealing with a rectangle, the perimeter is 2L plus 2W. So I just drew myself a simple rectangle with the widths labeled, lengths labeled. What I know is that one of the side measures was 8. So I know, and the overall area or perimeter was 36. So 36 equals 2L plus 2 times 8. So 36 equals 2L plus 16. Subtract the 16 from both sides. 20 equals 2 times L. Divide by 2. and L equals 10. So I know one side measure is 8, the other is 10. So to figure out the final answer for area, we would do 10 times 8, giving us 80 square units. Now in example 3, it asks us to find the area of the shaded region. So we're going to look at this additive property and work it backward, because we know the little white square here plus this gray space would add up to be this whole big rectangle. So what we can do is the area of the large rectangle minus the area of the smaller white rectangle to equal the area of our shaded region. So if the big rectangle is 15 long and 10 wide, we know its area is 150 square units. The smaller rectangular square in this case is 5 by 5, so its area is 25. So 150 minus the 25 leaves us with the area of the shaded region being 125 square units. Then let's look at example 4. It says, suppose a farm is 1/2 mile long by 1½ miles wide. How many square feet of land is this? So we know there are 5,280 feet in a mile. So to convert half a mile to feet, we would do 1/2 multiplied by 5,280, telling me that I have 2,640 feet. Then the 1½ miles, so 1.5 multiplied by 5,280, gives me 7,920 feet. So my area, in terms of square feet, would be 2,640 multiplied by 7,920, giving us 20,908,800 square feet. Then we get example 5, word scenario. It says, painters have been hired to paint one wall of an auditorium. They need to calculate how many gallons of paint they need to purchase for the job. The specifications are as follows. So the wall is 60 feet long and 18 feet high. So I just drew myself a rectangular wall, 60 feet long, 18 feet high. Then it tells us there's 5 windows on that wall that measure 3 feet by 7 feet each. So I drew in my 5 windows, and I know each of them are 3 by 7. Then they told us a gallon of paint is covering approximately 350 square feet. The wall needs 2 coats of paint, and each gallon is $14.95. So the first thing I want to do is just figure out the overall area of the wall with the windows. So I need to do 18 times 60, which gives me 1,080 square feet. Then I wanted to figure out the area of my 5 windows. So if each one is 3 by 7, each one's 21 square feet multiplied by 5, and we know the windows are 105 square feet total. So if I do the wall minus the windows, I know the wall without the windows is 975 square feet. Well, a gallon is covering 350. So 975 divided by the 350 says it would be approximately 2.79 gallons to cover that wall for 1 coat. But because they told us we needed 2 coats, we need to double that, giving us 5.58 gallons. Now, we're assuming you can't buy half or quarter gallons, so we would need to round up and purchase 6 gallons for the job. So then to figure out our final total, we would take our 6 gallons, multiply it by the $14.95 per gallon, telling us that the paint would cost approximately $89.70 for this job. So going back to the original part, we are just basing everything off this idea that area is the space covered by a two-dimensional region, and that the area postulate breaks down into these four key pieces.